Section 5.1, example 5, finding the maximum value of a quadratic function. A backyard farmer wants to enclose a rectangular space for a new garden with her fenced backyard. She has purchased 80 feet of wire fencing to enclose 3 sides, and she will use a section of the backyard as the 4th side. Find the formula for the area enclosed by the fence if the sides of fencing perpendicular to the existing fence have length L. Okay. I can't see it just by the words. Maybe you can, but I'm going to draw a picture just to make it a little bit easier for myself. So again, we have a farmer wants to enclose a rectangular space, new garden with her fence. Okay, so I'm going to imagine this being her garden. So that being her garden. And I'll imagine this being her fencing. Let's see if we have that right. So a backyard farmer wants to enclose a rectangular space for the new garden within her fenced backyard. She has purchased 80 feet of wire fencing to enclose 3 sides. All right, so we have 1, 2, and 3. 3 sides, and she will use a section of the back fence as the 4th side. So this one, we're not including that fencing. Find the formula of the area enclosed by fencing if the sides of the fencing perpendicular to the existing fence have length L. So we're calling this L here, which means this is L over here too, which means this here is going to be the width. So find a formula for the area. So we know that area is going to be our length times width. So let's start with that. So area is equal to length times width. Let's see, she has 80 feet of fencing already. So we know that this is going to be part of the fence. That's going to be part of the fence, and that's going to be part of the fence. So we know that the perimeter is going to be L plus W plus L. And we know that we have 80 feet to work with. So let's see. So we have, let's combine like terms here. I see we have 2L. 2 length plus width is equal to 80. And let's see, do they have a preference if we're in terms of length or if we're in terms of width? I find it easier to be in terms of length. So what I'm going to do is set this part of the equation equal to W. So minus 2L minus 2L. So width in this case is going to be our 80 minus 2L. All right, and what we could do is plug this in for W here. That way we have area in terms of L. So combining these two. So we have area is equal to length times width. Length times width, we just said was 80 minus 2 length. So now we could set this as a function. Area based on length, area in terms of length is equal to make it a little bit cleaner. Actually, no, we could just leave it like that. Length times 80 minus 2L. And there we go. Let's see, did we answer that question? Find a formula for the area enclosed by the fence if the sides of the fencing perpendicular to the existing fence have length L. I'd consider that a win. So we got that. And now what dimensions should she make her garden to maximize the enclosed area? So we want to see a max of area. So to maximize area, it looks already like we have a quadratic if we were to expand this. We have L squared, which is a quadratic function. We know that a quadratic is either going to have minimum values here or it's going to have a maximum value up here. And I think we end up with the maximum value. So let's find the vertex of our parabola. Let's rewrite our equation that we just made up in part A. L times 80 minus 2L. Let's expand this. So multiply L to both parts. We have 80L minus 2L squared. And it looks like we could complete the square here. So minus 2L squared plus 80L. Let's group those two terms together. We need a coefficient of 1 here, so let's factor out a -2. So we have L minus 40, or L squared minus 40L. And here we're going to find our magic number, half of B squared. So half of -40 squared. -40 divided by 2 is going to be -20 squared, which is 400. And just to make sure, let's check. 20 squared, 400, yes. So we're adding 400 inside and subtracting 400 outside. So plus 400 in here, minus 400 in here. But notice that this 400 is not just 400. It was that -2 times 400. So when we add it in here and subtract it out here, we need to multiply this one by that -2 as well. And there we go. -2 L, and we could grab this part for this part here. So -20 squared plus 4, that's 800. And we could set this equal to 0, see what we end up with. Actually, we don't have to set it equal to 0. So this is area in terms of length. And if you look at this, we have a vertex at 20,800. Which if we were to graph this and see exactly what we're talking about, it's a parabola opening downward because we have -a. Here we have 20. We'll say this up here is our 800. And we do something like this. So at length 20, we have the maximum area of 800. So what dimensions should she make her garden to maximize the enclosed area? So I'd say a length. So a length of 20. But we have to figure out what the width is. And we have a formula for width. So width is equal to 80 minus 2L. So we could come over here. Width is equal to 80 minus 2L. Length in this case is 20. So 80 minus 2 times 20. So 80 minus 40, which is 40. So we have length 20, width 40. And that's it. These are the dimensions that the farmer should use to create her fencing and maximize the area. Perfect. If you have any questions, please feel free to ask. Otherwise, bye.